name is Andreas Klein. I will host the first half of the talks for you. And I'm very happy to have Paulus Esterhazy with me, our first speaker. It's his fourth talk at clojureD/U. And what I always enjoy with his talks is that he asks the difficult questions. Most of us ask, how can we do something? But he most of the time asks, why should we do it? Should we do it at all? And he will do his talk about automated testing. What is the point? Very good question, by the way.
Okay. All right. So the title of my talk today is Automated Testing. What's the point? So in the course of my career, I've been doing unit testing on and off. I've been doing TDD, test-driven development, on and off. But lately, I've been asking myself this question. What's the point? Why bother? Why go to all the trouble of writing all of those unit tests? But before we get into that, I want to ask you a question. Does anyone know what this symbol means? So it's a dolphin that's wrapped around an anchor. And this is actually an ancient symbol, that's been in use for 2,000 years. And it's kind of a combination of two contradictory ideas. So there's the dolphin on the one hand. The dolphin is, gliding through the waves. It's fast, it's nimble, it's agile. And then there's the anchor, which is robust. It's keeping you safe. And it's also weighing you down. It's slowing you down, right? So you have these two ideas that don't quite fit together. We have the fast dolphin and the slow anchor. So this symbol has been used for a really long time to refer to this Latin adage. And that's Festina lente. In English, that means make haste slowly. Or to paraphrase in my own words, it's something like, in order to go fast, you need to go slow. And I think the image really illustrates this idea pretty well. This image became famous in the Renaissance because of this guy, Aldus Manutius, who was a printer who worked around the turn of the 16th century. And he used this image as his printer's mark. A printer's mark is something you put in the beginning of your book to identify the printer who made the book. And he was one of the most famous publishers of books at the time. And he was a big innovator as well. So he was notable for being one of the first people to print books in Greek. He printed the Odyssey, the complete works of Plato, Aristotle. So you can see Aristotle here on the left-hand side. And what he did was to make available those classics in the original language so people would be able to read them in Greek. He was also notable for commissioning a new typeface, which was kind of like letters printed in the slanted way, imitating the cursive, the handwriting of the time. And that became known as italic font because Aldus was working in Venice, which was in Italy. So he was the person who initiated italic fonts. So I find this figure really fascinating because he was this technical innovator. He was a cultural innovator. He was a kind of a startup founder, right? He had a business, this printing press, printing office. And he was in the midst of this technological revolution. The printing press had just been invented 50 years before he set up his shop. And it was this time when the spread of knowledge was accelerating. information was traveling faster than it had ever before. And yet there was this guy, Aldous Manutius, in the middle of the whole thing, and he was telling us, Festina lente, make haste slowly. He was cautioning us to slow down in order to go fast. Okay, so in the Renaissance, making books was a cutthroat business. It was really expensive to buy the paper. The ink was expensive. It was difficult to make the typeface. And that had as a result that a lot of the printers went out of business after a year and a half. They printed one book and they went bankrupt. So they ran out of VC funding and then they had to close up shop. And in order to make it on the market, you had to be fast. You had to go fast so that you didn't have to go out of business. And I think the same is true for us today as software developers. So, do we succeed in shipping software fast? And the answer is yes and no. It's mostly no. And you can kind of see it plotted on this graph. So on the x-axis of this graph, you can see the progress of the project. So that would be features shipped in the product, value delivered to the customer. And you can see that at the beginning, on the y-axis, you can see the total effort that is required to get to that point, the total cost of getting there. And you can see at the beginning, the cost is increasing in a modest way. And that's because the team is shipping new features, it's churning out features, it's having a lot of fun doing it. And it feels like it's wearing these 7-league boots. It's making really fast progress. But before they know it, there start to be these slowdowns. And a feature that used to take a week now takes 3 weeks or maybe 4 weeks to implement. So that's the time when software entropy is starting to show up and the changes are getting harder and harder and progress is becoming sluggish. And you can see that the cost is rising in this hyperlinear way. So that's a pretty common trajectory. I'm sure that a lot of people here have witnessed something like this. But that's not what we wanted. That's not what we set out to do. We don't start out projects with this expectation that we have this initial burst of productivity in the team followed by this long tail of ever-increasing cost. So what we wanted was more something like this dotted line. What we wanted was sustainable growth, where the cost is increasing in proportion to the progress that you're making. And that means that a feature that you develop 3 years into the project would take about the same amount of effort that it did at the beginning of the project. That's what we really want in software development. And I think that's the fundamental challenge for us as software engineers. How do you manage to flatten this curve? How do you flatten this cost of change curve so that fast software delivery doesn't just mean fast at the beginning, but fast, sustainable growth of the project? Okay, so that's the claim that I want to make today. I'm guessing you're already wondering what all of this has to do with automated testing. And that's the claim that I want to make today. Automated testing is something that helps you flatten this cost of change curve. It helps you achieve sustainable growth. I want to make it clear from the beginning that I don't think it's a silver bullet, because there's no silver bullet. There's nothing that can guarantee that you will still be able to make changes cheaply 3 years into the project. But automated testing is one of the best techniques, one of the best tools in the toolbox that we have for getting there. So what do I mean when I'm talking about automated testing? I'm not primarily talking about end-to-end tests, Cypress tests and things like this. And I'm not saying those are not valuable. I think they're very valuable and you should have them in your project. But I don't think they can sustain the type of development that I'm arguing for here. So I'm not going to talk about those today. Instead, I want to talk about unit tests. And there's another problem with this, which is that this is a terminological minefield. No two developers can really agree on the definition of a unit test. And there's no ends of argument around semantics there. So instead of entering this minefield, I want to sidestep the whole issue by choosing a different term. So instead of unit tests, I mean, I want to talk about unit tests, but I'm going to use a different word. And that's not a word that I came up with, but I really like this word and the connotations that it has. So I want to talk about microtests. What is a microtest? A microtest is a small, fast-running check that verifies a particular path through your production code. Okay, so just briefly taking those definitional elements in reverse order. So it's a check that verifies a particular path. By that I mean that the check, the test, doesn't consider your system as a whole. It's not a whole system test. Instead, it focuses on one particular aspect of the system. It's supposed to be fast, and by fast, I mean fast. You're supposed to get feedback from the test runner in 5 seconds, maybe 10 seconds, but no longer than that. And that puts some constraints on what you can do in those tests, because you want to be running hundreds or thousands of tests per second, because you're going to have a lot of these microtests, on the order of thousands of microtests at least. And then finally, the test should be small. And by that I really mean simple. If you have this arrange, act, assert, tripartite structure of a test, the arrange part shouldn't be 100 lines of code. That's a sign that your production code that you're trying to test is too complex. Okay, so that's all I'm going to say about the how of testing. I'm going to focus on the why. And the reason why I'm doing it is because people keep telling you that you should be testing your code, but they're using this moralistic tone, they're kind of judgy about it, and I don't think it's very productive. And it's not effective because it doesn't make people understand the rationale behind the practice. And I don't think it's a matter of morals at all. It's about economics. It's about the economics of development. So that's what I want to focus on. Now, today I'm convinced that automated testing is worth the investment. It's a really good investment, one of the best investments you can make. But I used to be skeptical. I didn't used to think that way. And the reason why I was skeptical was I had this implicit assumption. I was assuming that eliminating bugs was the point of automated testing. And if that's the goal, then it wasn't entirely convincing. The value proposition wasn't clear to me. Because there is a significant cost to microtesting. If you're writing like a one-to-one ratio of test code to production code, then you're going to be writing twice as much code as you would otherwise. That means you have twice as much code to maintain, and that's a significant cost. And also, there's this alternative to automated testing, which is manual testing. You just open the app, type in some credit card information here, shipping address there, customer name here, press submit, and then you can check if the result is what you expected. So that's the status quo. Right? Manual verification of changes, manual regression testing. G. Paul Hill calls this geek at keyboard activity, and I think the phrase really captures what you're doing. You're kind of at the keyboard and verifying that everything's still working. Now, given the fact that automated testing is expensive, and I have this alternative manual testing, why should we go to all the trouble? So what made automated testing click for me was changing the way I think about it. And I don't think it's about eliminating bugs, at least not primarily. Instead, I think it's about feedback. It's about getting this high-quality, fast feedback constantly during development. Okay, so how does this work? What mechanism is in place that allows automated testing to give you this high-quality feedback? Well, the first thing that you're probably thinking of, rightly, is the red-green refactor loop. So it goes it goes something like this. You come up with this idea of a feature. Then you think about how am I going to be writing test code that forces me to write production code that I want. So you have to reason a little bit backwards. Then you write the failing test. Then you write the code that makes the test pass. You go to green. Before that, you make sure that you see the test fail. Then you see it succeed. And then you're on the green bar, and then you get this chance to refactor the code. You can, for example, if you have a 4 in the code, you can see if wouldn't this be more readable if I used map instead. You can just make the change. 5 seconds later, you get a result. You get a confirmation that it's still working. Notice how this improves the development experience compared to the status quo. One thing that I like to do, and I always wonder why people don't do it as much, is to add a sound effect. Maybe they don't want to annoy their neighbors. But yeah, I really like to add a sound effect to my test runner so that if the tests pass, I get like a nice chime, and if the tests fail, I get a more ugly sound. And that makes you feel really connected to the code that you're writing. Gives you this immediate, almost physical kind of feedback. And you get this dopamine hit whenever you make a test pass, which could be as often as once per minute. You get a nice feeling. And that's really important. Now compare this to the status quo. In the status quo, remember, the way you verify your changes is you open the app, you type in the credit card information, you typing the shipping address, you're adding the customer name, you press submit, and you check if the result is what you expected. And that's repetitive, and human beings are not very good at repetitive tasks. So they're not very reliable at it, so you don't trust the feedback. I mean, it's still feedback, but it's not very high quality feedback. And notice that it's also an order of magnitude slower than what the automated tests give you. So instead of 5 seconds, 1, 2, 3, 4, 5, you have to wait for 5 minutes or something like this. And you have this fixed cost that you have to pay every time you verify a change, the cost of going through this repetitive task. And that kind of nudges you into the direction of making bigger changes. You batch up your changes, you do more things, and that's not a good thing, because that makes the changes themselves more risky. It increases your cognitive overhead, and that means that you can't use your brain power for other more important things like software design. So you can't really reduce manual testing to 0. That's never going to be possible. But you can really reduce it down. You can really reduce it to 10% of what you're doing in the status quo. And that means that the economics of automated testing change because, basically because the geek at keyboard activity takes up so much of our daily work hours. So even if you're spending twice as much time actually coding, you might still come out ahead faster with the automated tests because you're spending so much less time doing this poking around the application. And then finally, I want to share a kind of a life hack, something I really like to do, which is predicting out loud what the result of your test is going to be. So it goes something like this. You write a failing test, but before you trigger the test run, you go, this test is going to fail, and it's going to say, undefined is not a function. And then you run the test, and you compare that against your expectation, against your guess. And then you can check your mental model of reality against reality itself. And that gives you the opportunity to know where you don't fully understand what you're doing. The most flabbergasting type of feedback is when you expect the tests to fail and they actually passed. All of this gives you this amazing learning opportunity. You can learn about the language that you're using, Clojure or Clojure script. You can learn about the code base that you're in and also about the problem domain. Okay, so all of this has been about feedback about the behavior of your system. But there's also something equally interesting, which is not about the behavior of the system, but about the internal software quality. Automated tests also give you feedback about the internal construction of your system. So recall this graph of unsustainable growth, right? Remember, you start out going fast, and then at some point you go more and more slowly. And why is that the case? What's driving those rising costs of change? I think there are two things here. One is that you're no longer in the greenfielding phase. You're no longer in the phase where the team is just creating new source files, adding new features. But instead, what you're doing most of the time is editing existing code files. And that's inherently harder than creating things from scratch. And the second thing is that the architecture that the team came up with was an architecture that made it really hard to make changes to the code. Now, what can we do about this? We can't change the fact that you're going to be brownfielding. You can't change the fact that modification of code will dominate. It's just a fact of life that we spend most of our time changing existing code rather than creating new code, as much as we would like it to be different. So the only lever we have, the only thing we can do to improve things, to get this nice flat cost of change curve, is to improve the design of our software. And automated testing helps with that. Automated testing helps you avoid this big ball of mud architecture where everything depends on everything. And the reason is, I think in a nutshell, that you're forced to confront this reality of software design earlier on in the development process. You're forced to face these design problems during this test-driven development loop. Because at the beginning of this red-green refactor loop, there's actually kind of a hidden extra step where you have to think about what's the interface that I'm going to design, what's the argument structure of the function that I'm going to write. And you have to consciously think about the design that you want. And that has a powerful effect. To see this, think about the typical experience of adding code to legacy. Adding tests, retrofitting tests on legacy code, on existing code that you didn't write in this test-first style. And the typical experience is it's really hard. It's hard to get the code on a test because the code relies on this global state that's defined over here. And the code has all of these awkward dependencies on things that do I/O, that talk to the database, and so on. So there's two reactions you can have to that. The one is kind of throw up your hands and go, I give up, testing is hard. But the other reaction is, and the one that I prefer, which is to take that as a message about the code that you wrote. There's something wrong about the code that you wrote that made it hard to write a test for it. So you can understand what the test is doing as giving you feedback. It's cry for help that tells you that you should fix your software design. Why is that important? That's because of this correlation between testability on the one hand, modifiability on the other hand. You have all of these aspects, like global state is bad because you can't apply local reasoning, right? So the ability to apply local reasoning is really important. Awkward dependencies are bad because they're a sign of high degree of coupling. And we know that high degree of coupling is also something that makes it hard to modify the code. So it happens to be the case that all of these qualities that make the code hard to test are also qualities that make the code hard to modify. And that in turn means that you can improve the modifiability of your code, you can improve the architecture of your code by improving the testability. And what better way to improve the testability of your code than to actually write the tests? So automated testing puts this positive design pressure on your code base. It nudges the code in the right direction. You still need experience, you still need judgment, domain expertise, and so on to write good code. Automated testing is not magical dust that you can sprinkle on your code that fixes the design problems. But it does give you this crucial feedback. It tells you how well you're doing on all of these metrics, on cohesion and coupling and so on. It gives you a warning if you're not on the right track, and then you can adapt and you can change course. So, Festina lente, make haste slowly. Thank you very much.